Welcome everybody to my talk. Like we said, I'm going to talk about how I learned to stop worrying and love and embrace vibe coding. I'm not sure I would exactly call it vibe coding, but AI assisted coding, right? So pretty much everything that I do nowadays has some sort of AI component, whether I'm writing it for an AI consumer or I'm leveraging AI to write it. I'm pretty much obsessed with this. I quit my day job 2 years ago to just do 100% this, and I love it. 2 thumbs up, would recommend. So a little bit about me. I live in Pittsburgh, so I actually flew down here because I'm going to Columbus tomorrow, unfortunately, but not too far away from the DC area, and I'm here regularly. I think I will be back here 3 more times before the end of the calendar year. I, like we mentioned, work at a company called Zenable that helps with AI coding agents, making things production ready. I teach for SANS. SANS is specific to security training for professionals, and there's a generative AI security class and a DevSecOps cloud native security class that I teach there. And I also do a lot of open source work. So I'm wearing my ambassador shirt today. I saw the ambassador logo a couple of slides before, so that was super awesome. So I'm a CNCF ambassador. If you're not familiar with that means that I have giant piles of stickers in my backpack, and I'm willing to give them out to you for pretty much all of the CNCF projects. Really what it means is that I volunteer a lot of my time for the CNCF, so that's Kubernetes and the associated projects. But yes, they do give me $600 worth of stickers every year, and I have to get rid of them. Oh, and I also organize a conference. So in Pittsburgh, we have a thing called B-Sides Pittsburgh. It's about 1,000-person security-focused event. And we just had it a few months ago. If you ever would like to come up, it's in June or July every year. All right, so who here knows what vibe coding is? Who's heard of this? All right, keep your hand up if you like vibe coding, if you do it yourself, if it's painful for you. Okay, cool. So if you're not familiar with what vibe coding is, this is kind of the origin of it. It was a tweet or an X post. I don't really know what to call it anymore. But Andrej Karpathy, which is a really popular person in the LLM and AI world, said there's a new type of coding. I call it vibe coding, where you fully give into the vibes, embrace exponentials, and forget that the code even exists. The idea is that you're not necessarily as focused on the line-by-line code and reading it yourself, and you're more focused on, like, does it work? Does it accomplish the end result that I want? And so you might have things that you want it to do and things that you might want your code not to be able to do. And that could be tested kind of at the end result without you needing to focus on the line-by-line code individually. At least that's the concept. And all my background for 20 years, I've been in cybersecurity. So if you think you're afraid from this stuff, I am just as well. But we'll talk about some of the kind of mitigations and things that you can put in place to actually adopt and embrace AI coding. And if you think that this is just for kind of amateur POC projects, that's absolutely not the case. So here we've got Leo posting again on Twitter. My SaaS was built with Cursor, 0 handwritten code. It's not just an assistant, it's also the builder. You can whine about it or start building. P.S. Yes, people pay for it. So Leo here feels like he's doing a great job. This is a real person or a real fictional person on X, I'm not sure which. And this is a very interesting thread. It's become very popular after the fact, but I remember watching this happen live and I'm like, this is hilarious and I love it. And you can see there's only 610 hearts on this. I thought it was more popular than that. But anyways, so yes, people pay for it, vibe code entirely. Guys, I'm under attack. Ever since I started to share how I'm using my SaaS, random things are happening. Maxed out on usage, API keys, creating random stuff in the database. Like, things are not going well. Like, or is he under attack? Or maybe is this just like a symptom of a vibe coding, like low quality code, right? Okay. As you know, I'm not technical, so this is taking me longer. All right, but you know what? I think we can solve this problem. Let's just double down. I just vibe coded out of a cyber attack. Ask me anything, right? So just double down, right? Just keep using more and more AI, more and more tokens, vibe code your way out of these cyber attacks. Ultimately, it didn't work out. Leo ended up shutting down his application. I just can't handle this, too much of a headache, and moved things over to a different platform to Bubble, a low-code, no-code platform, and said, I appreciate all the help, but this thing's just an unmanageable train wreck. Now, this was back in March. I would say that a lot of things have changed and nothing has changed. uh, these models, we keep releasing newer and newer models, and it's very interesting, very powerful. And you'll see posts like this. Cloud4 just refactored my whole code base in one call. 25 tool invokes, 3,000 new lines, 12 new files. It modularized everything, broke up the spaghetti. None of it worked, but boy, was it beautiful. Right? So this is that convincing. It's kind of convincingly good, right? It looks great. I can tell you story after story after story of me performing a PR review of AI code and saying like, oh, that's really weird how it did that. And even the person who opened the PR said, yeah, weird, huh? Then it ships to production, breaks production. We do a root cause analysis. Oh, wait, that line of code that we thought was weird and was pretty convincing? Yeah, not right. And sometimes the way that the code, again, if you're not looking at the code itself and you're just focusing on the output, sometimes the way that it works might be a little bit more something like this, right? So does the water go down the pipe? If you're just measuring if the water goes down the pipe, this is perfectly fine, right? But if you want to write something that's production ready, maybe, a bit of an additional rainwater, and then things are going to be going all over the ground. It's not going to work out well, right? So this is maybe if you just vibe code with, one-shot prompting and take that code, ship it to production, this is probably what you're going to be working with best case. So because this is a DevOps group, I open sourced a tool which I call AI native Python. We're going to just do a speed run of that. It's a paved road. Does everyone know what a paved road is? Familiar with this concept? Yeah, I see a lot of heads nodding. So if you're not familiar, a paved road is if you're starting a new project, how do we start on the right path, right? Like if I was put in the middle of a field and I need to kind of like take this car and go somewhere, is it going to be faster to like drive over the hills and the grass and the dirt or whatever, or to have a paved road that's like already kind of flat and fast? We prefer the paved road, right? And so the project that I have is AI native Python, and I'm just crazy enough to do a live demo of this thing, so let's give it a shot. So what this project is, it's going to create some Python, that moved all the way down there. Okay, let's just move this again. Oh, I see. The AV people auto-adjusted it for me. I just won't touch it again, sorry. So what this is going to do is generate some Python code, which is 100% tested. It has a Docker file with it. So if you want to do dev containers, you've got a container ready to go. It's got pipelines, linters, pre-commit, all kinds of great stuff. It's the generally good practice stuff. It's nothing that's going to be specific. It's not going to write your code for you. This is all of the scaffolding that you want to be in place when you're creating a new project. We're just going to show generally what that looks like. So kind of nothing up my sleeve, right? There's no images here. No digests have been pushed, and this is on Docker Hub. We're going to build and push something to Docker Hub today. And the way that I'm going to do it to start is I'm going to run this command, and I'm just going to call the project name DevOps Days DC25. I've pre-created a Git repository that's empty with that name, and then I created that Docker Hub repository, which is empty with that name. So I've already downloaded this. That's great. We're going to call it DevSecOps Days 25. That's 5. And, oh, actually, no, I should not make that the project slug. Oh, I just broke my demo. Why did I do this? All right. Let's start again. So we're going to run this command. We're going to keep the project name in slug, and then we can call the description. Let's vibe. Company name is going to be Jon Zeolla, jonzeolla.com. Jon Zeolla is the GitHub org. I'm the owner. Let's do Python 3.13 because I like new things. Yeah, let's put it in Docker Hub. It's going to be public, and I'm a fan of the MIT clause, so we're going to make this MIT. So I answered 11 questions. Pretty simple. And it's doing some cool stuff for me now. It created a repository, and there we go. It actually cut our first release. So all of this code and documentation on how to use this code, instructions for a bunch of different AI agents. We've got some source code. We've got some helper scripts. We've got a whole bunch of stuff, right? So let's just take a very quick tour of it. We're going to cd into that repository locally. And we're going to look for this not implemented error. These are placeholders. Once you run the paved road, this is where you should stick the actual business logic code. We've made all the scaffolding. You got to write the business logic, right? There are lots of things that we can do. We can lint it, and we've got these pre-commit checks. We're going to make sure that you don't have hard-coded credentials, that your JSON and YAML files are valid, that the end of files are correct, blah, 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 that you don't have typos. All that stuff is going to happen automatically. Our goal here is you're going to start on the right path. You're starting on this paved road. And when we get back to kind of the vibe coding angle, if you give AI a good baseline, a good initial environment to work within, it's going to continue to follow those patterns for the most part. If you give it an empty directory and you say, do these things, it's going to invent things that are generally pretty bad practices, right? And so our goal here is to set it up on a paved road so that it can continue following established design patterns that we say are good. So this is the whole repository that we just created and all of these different files and stuff. We have GitHub actions and pipelines. So we've got the ability to do a PR review check with tests, commit, stage checks, cut releases, do security things. It even auto updates itself. So I think twice a week, it'll open a PR against itself, fully updating itself. So you don't even have to worry about maintenance. You can run unit tests, and those all passed. You can see here with 100% coverage, just doing basic things like configuring inputs, doing command line argument parsing, logging levels, things that everybody pretty much needs. That's cut a release, because why not? Hopefully this works. It worked last time. See down there? It worked last time, so it should work this time. So we are now cutting a release. Let's see, what's our next command? All right, so the next command is we're actually going to run this thing. So we need to give it a minute. It's building in a pipeline, releasing it to Docker Hub, and then we'll check it out, and we'll be able to pull and run it in a second. But since this is only a 30-minute talk, and I'm about halfway through it, we're going to just keep on moving. We'll check back up on that later. So I love this AI stuff, right? And so in the evenings, when I watch TV, I watch a lot of YouTube. And here are a couple of snippets of things that I like to watch on YouTube, which is the intersection of enjoying myself and learning a little bit about AI. And there are these videos where people use AI and machine learning to train models to learn how to walk or run or what have you, right? And so when an AI starts to learn how to walk, it looks a little bit something like this. It's not working so great. It gets a little bit better. Oh, look, this yellow one right here is starting to kind of edge forward. And eventually, like, it actually does walk. Now, it doesn't walk the way you might think or imagine that it walks, but it does move forward. Oh, whoops. Right? And so again, when we're talking about vibe coding and we're just kind of measuring the output, we're focusing on, like, can the thing walk? And so here is an example of trying to make an AI bot run, and if we measure its output, man, that thing is fast, right? So Usain Bolt can run this in 9.58 seconds, and in this example, we did 7.38. So it might look interesting, right? And this is the kind of thing that we have to internalize. It might look interesting, but if the output works, right, is that all that we care about? Is that really what's important? Maybe, maybe not, right? I'm just going to give you one more example. I've got a bunch more, but this is probably my favorite example of an AI bowling. But the results, right? The results, right? So it might not work the way that you expect it to, but it can work. And so when we're doing vibe coding, a lot of this focus is on prompting, or what some people would call context engineering. Again, here's Jon Zeolla, the person who created vibe coding, talking about context engineering. And context engineering is, how do I craft just the right input to these LLMs when I'm asking it to do something? How do I give it the boundaries, the specifications of what we want? So enter spec-driven development. This is kind of the modern era of vibe coding, is what people are calling spec-driven development. What you do is you start by defining the specifications of the final output. Then you find ways to enforce that those specifications are always met by the output of the AI. And then again, we're back to not really caring about what the code looks like. Just does it follow our specifications? Now, if you've never written a specification before, you might not know exactly what that means. I'm going to give some tangible examples, some policy as code here as well. You might be able to write something in Gherkin, right? So Gherkin is a common language used for these sorts of things. So we were creating an item in an API. We have this scenario. And so given I have a valid JOT, and this is the payload, when I do a post, then the response, et cetera, right? So you're starting to describe in a semi-structured way. It's still human language-ish, but a semi-structured way, your specification, your requirements. Now, Gherkin is not the only language for this. In fact, there's a really cool language that I came across over the past few months called ears. And so ears has actually been around for more than a decade. And it was an attempt at writing better requirements. Has anyone here ever got a ticket and the acceptance criteria was like, it works? Yeah, right. So ears is a way to kind of formalize that, and it's seeing a lot of adoption in the AI space. And there's 6 different ways. I think I got them all right. I think there's 6 different ways that you can write ears. There are these ubiquitous requirements. Always foo, right? This should always be the case. Sometimes there's event-driven requirements. So when this, then that. There's unwanted behavior. Never do this thing. And there's complex requirements. And there's a whole kind of structure for how you describe these. I gave just one quick example here. And again, this is just really a sentence. But it's a way to make sure that the requirement syntax has all of the information needed to be a useful specification to an LLM. Because remember, when you're prompting the LLM, you have all this kind of implicit information in your head. When you're trying to vibe code or even just write a script or do some Terraform or whatever you're working on, you've got additional context in your head that you never told the LLM. And it's going to try to figure it out. And usually it's wrong. Ears, Gherkin, other sorts of specifications are ways that you can fill in that gap. Now, there's other ways that you could do this as well. So not just context engineering or specifications like providing this input, but you can test the outputs, right? And so if you're familiar with the cloud native ecosystem, we have policy as code, right? In cloud native and CNCF policy as code, the Open Policy Agent project and Rigo and Kyverno and lots of different projects have, I wouldn't say popularized, but they've been working on this policy as code approach. And so there's lots of examples on how you can apply that to what you're doing as well. And so this is a little bit more deterministic. Whereas before, what we're saying is give good context to the LLM so it knows what to do. Here, what we're saying is when it's done, other than just clicking around in the UI, how do I make sure that it conforms to my expectations? So I call these conformance tests. You could use a tool like conftest. So this comes from the Open Policy Agent project. You're going to write it in Rigo. And here we're checking a Docker container. So we're saying the from, I don't even remember what the example is. The from cannot have, the Docker file can't have a from for an image in the deny list, which is Nginx, right? So we're saying deny list. We're not allowing Nginx. You could have an allow list. Only allow these internal projects. Only allow things from our internal registry. Whatever your requirements are, you can start to build these for it. And so when an AI writes a Docker file and it says from Docker Hub or from implicit registry on the internet, and you don't want to allow that, this would check. This would fail, right? This would be a CI failure or a deployment failure. You can also do GAUS. GAUS is similar to conftest, except it happens after it's built and when it's running. So think of a Docker run, daemonize, remotely connect into it, and see if it's listening on port 22. See if it has a config file that has some specific attributes that you want. Just a different way to check a running or after the build container images as opposed to conftest, which would run on the Docker file itself. Or you could do something like inspec. Inspec comes from the Chef project. You've deployed a server on in EC2 instance or VM in Azure or whatever, and you want to SSH in and do some checking. Inspec is really great for that. Here we're checking a bunch of SSH configurations. I just wanted to give a couple of examples if you weren't familiar with this, and you can kind of like branch out from here, or I'm going to be hanging around all day. Feel free to ask me questions about specific policy as code languages. It's a very niche ecosystem, meaning there's many different languages that are good at a very small area. They have a very small coverage, and you have to kind of like assemble the right ones for the job And going back to the beginning, our goal is to check if the output of an AI is conformant. So whether that's for quality reasons, for security reasons, for just speed reasons, so that you're not deploying something that's literally broken. But we've got other questions, right? So this is all great if I know what my requirements are. But who here feels like they know what their requirements are? No, I think it was in Jon's talk this morning. No company knows what their own requirements are, right? No, I absolutely don't. Right? I've worked at many large companies, and I worked on the security team that wrote the policies that people are supposed to follow, and I didn't know what was in all of the policies all of the time. So how could anybody else possibly be expected to know this stuff? It's complicated. So how do you start to get your arms around it? I don't think there's any expectation of perfection here for any reasonably sized company, as in a 20-person company. I think it would be hard to always know what all of your requirements are. Because even if you knew what the requirements were yesterday, what if you signed a new contract? That contract has requirements in it at the bottom. Now you have to follow this new thing, but you never were even told that that contract was signed. How could you possibly know what your requirements are? So for this, I'm a huge fan of knowledge graphs. So knowledge graphs are a fancy term for graph databases with a bunch of information in it. They look a little bit of something like this. This is just eye candy. It doesn't actually say anything in particular, but you can see that we have relationships between entities. You could think of this as cause and effect, or why, or context, provenance. This requirement applies to my Kubernetes cluster if that Kubernetes cluster hosts workloads that serve customer A, because this is in customer A's contract. Bunch of different nodes and edges in a and you kind of connect it together. Now, this is the result of me parsing a single, 20-page document into a knowledge graph. If you work at a reasonably sized company, it's going to be a huge mess. It's probably going to look like this, right? And so you're going to have to detangle this. How are you going to actually make a knowledge graph that works for your environment? I would suggest very slowly, iteratively, over time, right? Start somewhere and get better. This is a DevOps crowd. I don't have to tell you about continuous improvement, but just having something, experimenting, testing, and trying new things out, and just continuously trying to get better. How can I use the knowledge graph to inform the context of the specifications that go in when people are prompting? How can I use this context to create policy as code, to create conf test requirements, and to check things in CI? So that they aren't going to production when they don't meet our company's requirements. Then how can I push that all the way down onto the laptop, right? Whenever I'm actually vibe coding or writing code, how do I get that before I open up pull requests? Because I might do many, many, many different iterations. And I don't want to have to wait until the end of my feature branch to know that some foundational approach was very wrong. All right, so let's go back over to here. Check it out. My release has a green check. If I refresh this, I've got some 010 image released. All right, let's just see if I can pull this and run help. There we go. Cool. So I built and deployed a fully functional image, a container image, using that paved road. That gives you a place to start. You can then jump into that with an AI tool or any other paved road. What I'm not saying is use my paved road. What I am saying is use a paved road. Make a paved road. If you want an example, mine's open source. You can poke around at it. But make a paved road. When you're using AI tools, start with a base that makes sense. Make lots of changes and iterations on top of that base. Make sure that you think about your context, the input to this system. And as much as you can, start conforming the output to your expectations as well. Automate everything, right? Automate every single step of this as much as you can and kind of iterate and keep getting better. In a different form of this talk, I actually vibe coded a feature live, and it worked. I promise it worked. You can watch the recording of that. I didn't have enough time to vibe code something in 30 minutes, though, but that would have been fun as well. All right. So I wanted to leave just a couple of minutes for questions. This was a lot. Are there any questions from the crowd about anything that I talked about? Yeah, in the back.
I've heard about spec-driven development. Sounds like a lot of writing, but isn't that similar to Terraform? You write what you want the end result to be. And even though humans have written, open source HashiCorp, how you get that there, similar to declarative, like a declarative configuration, like at the end of whatever your vibe stuff, make sure this is there and it performs that way.
Yeah, it could be. The most popular current approach to spec-driven development is actually a three-step process. You start by asking an LLM to purely do research and don't focus on solving the problem, but just find out what currently exists. And so this is just a way so that you don't have to manually do that research and tell the LLM yourself. You just say, go read my code base and find the existing what have you. Then after you do the research, you make a plan or a PRD. And so you say, given this research, which I as a human have groomed to make sure that it's correct, let's put together a plan for how we're going to actually solve this problem. And then the human's job is to review the research and to review the plan. If the research and the plan is correct, then you say, go do it. And that's kind of like another way to develop a specification. So like the gherkin and the ears would be something that you would input at the planning stage. So you'd say, go do research. Now planning based on the research and these requirements in ears format and gherkin and whatever, give me an implementation plan, review the implementation plan. Yes, that meets my requirements. Then you're actually going to execute it. And there's all kinds of checkpointing approaches where you tell it to implement a feature at a time and commit it locally. So you have kind of like checkpoints using Git, which is really nice. And there's a whole bunch of other techniques, but hopefully that kind of answers your question a bit. Yeah. Awesome. I have 2.5 minutes left. Any other questions? Yeah. 2 more in the middle.
So you showed the example of the guy who coded up his SaaS and had a bunch of security issues. So how do you like think about the security issues in the output? You're vibe coding this stuff. Like, what do you kind of do to assess, like, is this secure or provide guardrails or safeguards around that?
Yeah, that's a great question. So I would say that AI generated code is no different than human created code. It needs to be checked in the same sorts of ways. The difficulty with it is that it comes at a much faster rate and it's usually longer. And so it's much more common nowadays that I get a pull request that's 1,000 lines changed. If you gave me a human written PR in the past, I'd say break it up, right? But it's becoming more and more common. Like you're pumping the brakes, you're slowing us all down by doing that additional review. So really, I would just say that you just need to treat it the same way that we used to. But all of the tools that we need to use, all of the DevOps principles still apply. We just need to do more of it faster, right? And the way I suggest to do that is fight fire with fire. If we're going to write code with it, why can't we write guardrails and pipelines and checks and things like that with it as well, right? And so we kind of need agents and other sorts of approaches to identify problems, and it'll work perfectly fine, just like human code, like we reviewed human code or AI code. We just need it faster. One more.
So one technique in the LLM space, besides the programmatic approach to validation, would be like an LLM as a judge.
Uh-huh.
Have you tried that technique at all?
Yeah, I do LLM as a judge a lot. So the idea is that you have one LLM creating an output and then another LLM whose job it is to judge that. People will do this a lot of times in, like, say you open Claude Code and you are generating some code and you say, check your work. That is a very low quality version of LLM as a judge. You almost always want to have a completely different context window, meaning that it doesn't know that an LLM created the code or anything else like that. So in Claude Code, I use subagents. And so you can have subagents check each other. They have separate context windows, and you could do LLM as a judge. In my startup, we actually we use LangGraph. And on the server side, when we generate code, we pass it through a series of different checks that go through different LLMs. And it's not just different prompts and different context, but sometimes we cherry pick different models that are better at different sorts of things. Or you can fine tune a model as well, which obviously we don't have time to talk about, but you can make a model specialize in a certain type of thing. And so I can have like a JSON checker or like a semgrep checker or whatever, or a GitHub Actions checker that's really specialized in that, fine tune a bunch of different models and then use those as judges. And then you can just return a structured output and say this was good or bad. I am a huge fan of LLM as a judge though. I use it all the time. Awesome. I'm out of time. I have the blinking red light. Thanks, everybody. I'll be hanging around if anyone has any questions. Bye.